Hello everyone and welcome back. Last time we left off by creating a character controller, and I think this time we will start getting into creating our world and make it more lively. And to do that, all I did was upload some assets and tiles that we will be using to create our world. As I said last time, all of the assets used will be available for you to download alongside the lessons. So I think we can get started. Now, we need to create a new scene, and we're going to choose a 2D scene, and we're going to get a node 2D. Let's double click it and rename it world, since it's going to be the root of our world. And I want to save it in the scenes folder, of course. We're just going to match the name here with a capital W. And I want to bring our player that we created into our world scene. And to do that, we're just going to select world. We're going to click on the chain icon. And here we'll have two scenes. Now, of course, we're going to select the player.tscn. And here we have our player in our new scene. Perfect. Now, to make this a bit better, we're going to create a tile map. We're going to select world and create the tile map. And in here, we're going to select the tile map and go all the way to tile set and change it from empty to new tile set. This will bring up this window. And if it doesn't, you'll find this window right over here. So you can just click it on your own. And in here, we're just going to have to drag and drop our tiles. In our case, it's called grass.png. And it'll say it will automatically define them for us. We can just click yes. But in this case, it won't work yet, because by default, the texture region is 16 by 16. But in our case, our tiles are 12 by 12. So we need to define a new texture region and then click on each one of them. Of course, if you're using other tiles that were not provided by this project, then you'll have to make sure what is the texture region for the tiles and then change it depending on the size of your tiles. Now, after we defined it, we can actually go to our tile map here, click on this button and select any of them, select the pen tool, and we can draw in our world. But we can notice a gap between our tiles. And that's because if we select tile set right over here on the right, and we can see the tile size is still 16 by 16. So we need to change this as well to 12 by 12. And now we have no gaps between our tiles. So this will hide our player though, so we need to change this. So we're going to select our player. We're going to go down to ordering. We're going to change the Z index to 2. Now our player is always on top of the tile map. So we have our tiles now. We can just try and paint something real quick. Let's put this down so we can see what we're painting. Tile map. And to draw big lines, big straight lines, all you need to do is hold shift and then drag. And this will let you make lines. And you can do it like so. So we can create a big square. And then select the fill tool or the bucket tool, and then just fill everything up straight away. Now you can see we are currently doing all of this on layer 0, but I want to name this layer and give it a better name. So we're going to call this ground. So now we're on the ground layer, and we also want to have another layer called crops that we won't use for now, but we will use in the future. And we're going to be drawing our crops on that layer. So we're actually changing its Z index to 1 since we want the crops to be on top of the ground. Perfect. Now, what I want to do is I want to have a function that will tell me where exactly is my mouse in the world. So to make it easier to understand, later on, I want to click on any of these tiles, and let's say I want to turn these tiles from grass to dirt. Not all of them, but just one of them. Yes. So if I click on this tile, I want it to turn into dirt. But how we're going to do that is we need to get the position in the tile map itself, and then we can get the exact tile in that position and then switch it up to one of the other tiles. We can switch it up to this dirt or water dirt or even the crops later on. So to do that, we're going to start off by selecting our world. We're going to create a world script. We're going to change the folder to scripts, so if we want to stay organized. We're going to hit create. And now, and now we're just going to have to go into our func process. And we're going to check. Actually, let's create an action for it first. So let's go into our input map and create an action called interact. I want this action to be my right mouse button, so we're going to click OK. And now we can do if input dot is action just pressed, and we're going to select our interact right here. If we interacted, if you clicked on the button to interact with the map, I want to get my mouse position. So we're going to do mouse pause, vector2, and I want to do get global mouse position. And this will give us our mouse position in the global world. Now, we can't really use this on the tile map, so we need to convert it to a tile map position. And to do that, first of all, I would like to reference the tile map. So we're going to do onReady var tile map, and it's going to be a tile map. And we're going to do tile map like so. So we don't really have to reference, so we don't need to reference it every time we are going to call the tile map, and we are going to call it a lot of times. So in this case, we're going to make another variable right now. We're going to do var tile map pause, and it's going to be a vector2i. And the difference between vector2 and vector2i is vector2 uses floats or decimal numbers, while vector2i only uses integers. And we need a vector2i when we are interacting with our tile map. So we're going to do vector2i equals tile map dot local to map. We're going to give it the position. So we're going to give it the mouse position right here. And it's going to take our mouse position and convert it to a tile map position. And I'll print both of them so you can see the difference. So we're going to do print mouse pause. We're going to also print the tile map pause. So you see the difference between this and that. We can just start the scene. And now if I right click, let's say here, this is the global mouse position, while this is the tile map position. It is not even remotely close. For example, this is the 0, 0 position. This is the first tile in the entire tile map. It's 0, 0, while our mouse position is 9.6 and etc. That's why we needed to do all of this. Now that we have our mouse position, we can actually set something up real quick. We can actually just change this real quick. We can change the tile just for testing purposes real quick. Let's do tile map dot set cell. And we're going to change this all. So it's asking us, let's actually make this a bit bigger so we can see. It's asking us for our layer first, then our coordinates, then the source ID, then the atlas coords, and then the alternative title, which we can just ignore. So we need these first. Now, for our layer, it's going to be 0, since we are using our ground layer. And our ground layer is on the z-index of 0. Or basically, it's like the first layer. So this is 0, this is 1. So crops is 1 and layer is 0. And so we can set that as 0. Now, it needs our coords, which is tile map pause. That's our coordinates. And now it needs our ground source ID. And the ground source ID is basically this, which position is this sprite sheet in. In our case, it's also 0. So we can bring it up real quick. So we can do 0 here as well. And it's also asking us for a atlas coordinate. And what basically the atlas coordinate is, it's a vector to I. And let's give you an example so it's easier. If you hover with your mouse, you can see the information that we needed in that function. In our case, it's source and atlas coordinates. Atlas coordinates is 0, 0. The next one is 1, 0. And the next one is 2, 0. And that's a vector to I. So some sprite sheets or tile sets have multiple rows. So it would change from, let's say in this example, 1, 0. If we had another thing over here, it would be 1, 1. And that's basically what our atlas coordinates are. In our case, it's 1, 0. So we're going to do a vector to I, and we're going to do 1, 0. And that's basically it. Let's try this out real quick and see if it works. Let's right click and it changes the tile that we click on to dirt. And that's basically it. We are just getting started, but we will take these basics and add more onto them, and then we will get to the finished product. And yeah, see you guys next time. Hello everyone and welcome back again. In today's lesson, we will be setting up our Godot project and get started on the game. What I want to do firstly is add a tiles, or let's say create tiles that we will use in our world. And to do that, I imported some 3D models that you will find linked along the course. And simply put, we're just going to drag and drop these tiles here. And we want them to be the parent node for now. So we're going to right click the tile and we're going to make scene root. We can delete this node 3D since we don't really need it. Now, let's reset the position of this tile right here. And we want to add a collision shape to it so that later on we can interact with this tile. And simply put, we can just select the tile and click over here on mesh, and we can just click on create trimest static body. And that will simply create a static body for us along with a collision shape. Of course, you can go along and create the static shape on your own and make a normal collision shape, let's say a box sphere, and try to fit it manually. But you can also avoid the hassle and use the button that I showed you earlier. And now, after we're done with this, we also want to change this once again, since I want the static body to be the parent node of the scene. We can now just rename it to tile grass, since this is what it is. Now, we can click Ctrl S to save this scene. And let's just create a new folders. Let's call it tiles, since we want to save all of our tiles in one folder. And let's save this tile grass in here. Now, making a tile for each of these models is a bit tedious. So what we're going to do is we're just going to duplicate it. Let's check which tile we want to do. First, let's do the tile dirt one. We can just duplicate this and change grass to dirt. Let's open up the dirt scene. Select your mesh right here. And since all of these tiles have the same size, you don't have to readjust the collision shape or anything. All you're going to have to do is select the mesh and drag and drop your tile right there. And it is perfect. I will not readjust the collision shape since this is going to be a top-down game. And we really don't need collisions that much other than for detecting raycasts, which we will go into later on. So for now, this is fine. We can save this, and then we will do the tile straight, for example. And we're going to have to do this for every single tile. So let's do tile straight. Oh, I made a typo here, so let's actually rename it and add a T at the end. Perfect. Open up this one. We're going to select the tile. It's going to do the same exact process. We're going to drag and drop the tile straight right in there. We can close the tiles that we finished. Now, we should actually do this in order. So let's do the corner square. What I can do is you can just click here, rename it, copy the name, and then just when you duplicate it, you can just paste the entire name, and that will be less of a hassle. Let's select our tile, and let's drag and drop our tile corner square. Let's do the end. So let's duplicate this, and straight to end, open it up, select our mesh, and drag and drop the mesh needed. Now we have and round spawn, so we're gonna do here, duplicate and round spawn. You can name these whatever you want, really. It doesn't change much since this is just a personal preference, and we can just drag this right here. We did the straight, and these are stuff that we won't be using right now, but we will be using later on. Now that we have all of our tiles ready, we can start creating our little world. We can just close these scenes up since we won't need them for now. And let's start by making a 3D node. So it's a node 3D. We'll rename it to world since this is going to be our world here. Nice. Now, what we can do is we're going to activate the snap. And now when we drag and drop our tiles, it snaps perfectly. Though you can see that it is not lining up with the grid that well. And that's because we need to go back here. We're going to offset these by a little bit. So instead of transform being 0, 0, on the X, I want it to be 0.5, and on the Z, I want it to be 0.5 as well. And that will be for all of them. I think I should have done this earlier, since we could have avoided all of the hassle, but it is fine to do this too. It doesn't take much time. We're just going to change this from 0 to 0.5. Oh, no, I selected the tile. Make sure you select the static body, so you move everything at the same time. Let's make sure that I moved the right thing here. Yes, I did. We can close the one that we did. Transform, and 0.5, and 0.5. We can close this, tile grass, and we're basically going to do this for all of our tiles. Now, tile straight. Let's also change this from 0 to 0.5. Oh, I changed the tile again. And this is our last tile. Perfect. Now if you can go back to our world, you will see it is perfectly lined up with the grid. And when we move it, it moves along our grid perfectly fine. Now, this part is up to you, whatever way you want to design your map. Personally, I would like to start with the end route spawner, although it's called the end route spawner, but we're going to be using it for the begin spawner. For some reason, it always go back to position 0, 0. Okay, perfect. And now we can rotate this however we want. Let's say I want it to be like so. And let's add a tile straight right here. As I said, all of this is preference. You can do this in whatever way you want. And now we won't have to drag stuff over again. What we can do is we can just Control D and then move it along the grid. And that's basically how we're going to design our map. So I want another one here. I want another corner here. Oh, which one is the corner? That one. And let's move it all the way over here so it lines up perfectly. Now I want more of the straight parts. So we're going to Control D. We're going to do Control D once more. And that way you can make a good looking map. Let's click our select tool, Control D to move it all the way here, and we can rotate it. And the same goes for all of our parts in this level. And we just need one more corner. Let's rotate it so it faces the correct direction. And we just need more straight parts, so we'll copy it and then place it right there. Now what we're missing is the end, which is this tile end. Just select it, reset the transform, and just move it all the way here. Perfect. And this is our little course, but we want it to look a bit prettier, so we're gonna add these grass tiles on the side. Let's reset the position and let's move it to where we want it to be. Let's actually add some right here, since they look really nice, because we don't want to have an empty path. Of course, you can decorate this however you want. If you want to, you can get more 3D models and put stuff around, trees, rocks. That's really up to you. But for the sake of simplicity, we'll just have this small field around the road. So we'll just finish up real quick by moving all of these here. Perfect. And yeah, this is basically our start. We have our map ready and we will start progressing more on the functionality. But for now, we have at least a base that we can start working with. And yeah. Hello everyone and welcome back. In today's lesson, we will be organizing a bit the project and getting started on the enemy path that will go through this road. And that's basically the main loop of our game. Now, to organize stuff, I want to create a node 3D. We'll call this map. And we're just going to put all of these tiles in that node. So later on, it is more organized when we add more components to the scene. We can close this up like so. Everything is contained in one node. And I also want to save our scenes. We didn't do that last time. And I want to create a new folder called scenes, since I always want my projects to be organized. And I'll save our world in the scenes folder. Now, to get started on the enemy path finding, or let's say path following, since it's a set path, there is a node that is specifically created for these cases, which is called a path 3D. Let's rename this to path only. Now, to create a path, all I have to do is click on the add point and then place these paths manually. Now, the easier way to do this is click on perspective here and put top view, and then you can just click on the point. Let's actually put one here, another one here, another one here, another one here, and here. Let's move up a bit. Let's put the last one there. Now, as you can see, these paths are not really on top of the ground, and we will need to fix them. We'll select this icon, which is the select tool for these points. I'm just gonna move them up just a little bit. Let's move them a little bit up. It keeps selecting the thing, but let's just try, and we don't want to rotate it, we want to move it. So let's see how we can do that without moving the entire path. I think we should disable the snapping. Yeah, that's an issue as well. And let's actually go to here. We need to pull this up a bit and pull it to the side. The same goes for this point. We want them to spawn right on top of this tile. Ooh, not too much to the right. And perfect. What we can do is to set a perfect Y value. We can select the path 3D. We're going to click on curves. We're going to click on points. And here we can see all of the position for our points. Now, for Y, let's actually set it up to 1. That's actually too high. Let's set it up to 0.2. I think that is good. Let's actually do 0.3. That's perfect. Let's do 0.3 for all of these points. And for the last, this one is 0 for some reasons. And all of them, let's put 0.3. So they're all on the same Y value, 0.3. Now, that's done. we can just fix these points a little bit by hand and go back and check that it's still on the same y value. Perfect. Our points look a bit nicer. Let's actually move this right here. And that's the second point. So we're gonna have to go check it again. So it is on the same y level. Perfect. Now our points, or our path, follows this small road that we have. And we're set now to start creating our first enemy. Perfect. And to do that, let's actually create a new scene for this. First off, let's save this up and then create a new scene. And let's start by adding something called a path follower. And this node is what we're gonna use to follow this path that we created right here. Let's rename this to UFO, since that's what will be the name of our enemy. Under it, I want to add a character body 3D. Let's call it enemy for the sake of not confusing ourselves with the same name twice. And of course, our enemy is gonna need a mesh instance. So let's add a mesh instance. And in here, we're gonna drag and drop one of our 3D models, which is right here, enemy UFO red.objects, and we're gonna drag it right there. We also need to create a collision shape for this. So we're gonna do a collision shape. And it doesn't really matter as much since their collision is only used to detect if they've been hit by, let's say, a tower that we made, or if they reach the goal. So it doesn't really have to be perfect or fed the mesh perfectly, but something like this would suffice. Now, we need to save this, and let's save it in a new folder. Let's call this mobs. So in case someone wants to expand on the game, the folder is already organized. So now that this is saved in our mobs folder, we can start with the basic UFO script. I actually want to attach it on the character controller, not the path follower, since attaching it here will be easier for us to access some of the functions in the character controller. So let's create a script, and let's create a folder, just like everything else, for scripts. So we're gonna do scripts and enemy.gd. We're gonna hit create. Perfect. Now we're gonna start working on our script. What our enemy needs is obviously a speed value. So we're gonna export it so you can edit it later on in the inspector. We're gonna do var speed. Our speed is going to be an integer. Let's say for now, let's set it for 2. And our enemy also needs a health variable. So we're gonna do health, and it's also an int. Let's say it has 15 HP. Now, we need to access the node that we made earlier, the path follower, since that's what we're gonna use to move our player. So what we're gonna do is we're gonna do onReady var path, and it's a type of path follower. That's the node that we used, and it's going to be our parent node. So we're just gonna do get parent, and that will basically get the node above our node, which is the path follower. Now, in our physics function, so we're gonna do func physics process. Here is where magic happens. We're gonna take the path follower that we have, we're gonna set the progress. So we're gonna do set progress. For some reasons, it doesn't show up, it doesn't autocomplete, but it is fine. We're gonna get the process that we already have. We have a function called getProcess. And we're gonna multiply it by our speed. And we're also gonna multiply it by delta. And this, basically what this does, it will make sure that the enemy will progress in the same speed, even if you have the game running on different machines with different frames per second. Now that we have this done, we want to check if our enemy reached let's say, reach the end goal here, reach the thing that we're trying to protect. So we're going to do if path dot get progress ratio, and if the progress ratio is more, or let's say equal to 99%, which means it already reached the objective, what we can do is we can just destroy this enemy. So we're just going to do Q3, which will delete it from our scene. And that is perfect. Now, actually, we should not do Q3, we should do path Q3, since the script is attached to a child of the UFO. So we're going to do path.q3. This way, we will delete the path right here. Perfect. And now, we'll just go and set it up in our world to see if it works or not. So what we need to do is, we need to create a script for our world. We're going to save it just like the other script in our scripts folder. And we're going to hit create. And now that we created our script, we can start creating our variables that are needed to make this functional. And first of all, we need to import that scene, or let's say our enemy, to our world script so we can instantiate it in the world scene. And to do that, we're going to do a onReady var. And let's call it enemy since it's our only enemy in the game right now. And it's going to be of type packed scene. I'm just going to preload the scene. And it's right here, mobs, UFO, that's what we called it. Perfect. Now that we have this ready, I want to create some extra variables that will help us spawn these enemies. First of all, I want to create a var, and we're going to call this enemies to spawn. And this is going to be the number of enemies we spawn in a round. So it's going to be of type int. And let's say we want to spawn three enemies. For this, let's say testing phase. We also want a variable that will check if we can spawn enemies or not. And what I mean by that is that we don't want our enemies to spawn in one go. We don't want a stack of 3 enemies to be on top of each other moving at the same time. We want them to spawn with a small delay between them. And that's what we're going to do here. We're going to create a variable called canSpawn. And it's going to be type boolean. I want it to be true by default. Now, what we need to do is, as I said earlier, we're going to have to create a timer. And to do that, we're just going to select our world. We're going to do add child node, and we're going to add a timer. Let's rename this timer to spawn timer. And we can just click on the spawn timer, go to node, and we're going to relate this signal, and we're going to attach it to our world script right here. Now, when this timer runs out, I want the I misspelled spawn here. We want the canSpawn variable to turn to true. I'll explain why in a second. CanSpawn equals to true. Now, let's create a function that will handle all of this for us, since we don't want it to be cluttered in the process function. We want the process function to be as clean as possible and divide all of our components into smaller functions. That's what we're going to do here. We're going to do something called func game manager, let's say. And it's going to be of type void. And in the game manager, I wanted to check if we can spawn enemies or not. So it's going to do an if enemies to spawn are more than 0. So we have 3 enemies to spawn. And we can't spawn. So canSpawn is true. Then I want this timer to start, so we can drag and drop it right here, .start. That way we start this timer, so this function can fire up after it's done. And now we want to instantiate our enemy. So we're going to do var temp enemy. We're going to do enemy dot instantiate. Perfect. Now, we're gonna get our path and spawn enemies as children of this path, since our UFO is a path follower, so it needs to be a children of this path. As you can see, you can click on this warning. A path follow 3D only works when set as a child of a path 3D node, and that's what we have right here. So we're gonna drag and drop it right here, and we're gonna do add child. We're gonna add our temp enemy right there. Now that we spawned our enemy successfully, we want to decrease the amount of enemies that we want to spawn by 1, and we want to set the can spawn to false. So this function doesn't fire up multiple times in one go, but it needs to wait for the timer to finish up. This basically should work, and we will just test it in a second. We just need to reference our function in the process function right here. We can go to 3D world. Oh, we did not set up a camera. I almost forgot about that. Let's actually set up a camera real quick, so we can add a camera 3D. Otherwise, we wouldn't be able to see what we made. So let's turn the camera 3D like so, and let's pull it up a bit. Let's put on perspective. Oh, that does not look quite right. Fix it quick. And it's a bit far. The camera is also just personal preference, the way you want your game to look like. It's simply just better to play around with the values of a camera to find the perfect positioning and rotation for it. Still feels a bit weird, but I think this is fine for now. We can test out our scene by clicking F6 on our keyboard or clicking on this icon here. And now, we have an issue which calls get process, non-function get process and base. Oh no, get progress. I wrote process by accident. Sorry about that, guys. We'll just replay it again. And as we can see, it did spawn, but it is not functioning correctly for some reasons. It is not moving like we hoped it would. And we need to find why it's doing so. Let's see. Path.set progress equals path.get progress timed by speed and delta. Oh, did I time it? I apologize. This needs to be a plus. Yeah. Small mistakes, sorry about that. And now it should work perfectly. As you can see, the enemies are spawning, and they're not spawning on top of each other, but they have a second delay. And when they reach the objective, they get deleted automatically, since that's what we have here in our enemy script. And that's basically our enemy path following script. That's all we need for now. For the health, we'll just edit for like when they reach the objective. We want the player health to decrease. We'll just add a couple of lines in the enemy script, but that's about it. That's as far as our enemy go. And that's perfect for now. And we can get into more complicated stuff in the next lessons. Hello everyone and welcome back. In today's lesson, we'll be going over on how to create a way for us to defeat these enemies before they reach their goal. And so we will be creating our first tower, which is going to be a cannon. And let's hop right into it. And to get started, we're going to create a new scene as always, and we're going to start with our tower. Now, our tower needs to be a static body 3D. And let's call it a cannon since it is a cannon. Let's actually do it with a capital. So it's a cannon. And now we want our cannon to have a mesh so we can see it. We luckily have a 3D model for our cannon, and it is right here, weapon cannon. We'll drag and drop this to the mesh, and here we have our small cannon. Now, we still need to add a collision shape, so we're going to add a collision shape to it. Collision shape. And we want this to be a box shape, and we want it to be like a platform, like so, just right under it. And this fits perfectly because it is the same size as our tiles. So when we place the cannon, it will just sit right on top of it, just like one of these tiles. And you will see why when I keep going more into details later on. Now, we can save this in our scenes folder. That's where we're going to save everything that is important. Now, what we need to add is a node that will indicate where the bullet should fire from in this cannon. And to do that, we're going to add a node that's called aim 3D. I think that was what it was called in Godot 3. What is it called in Godot 4? Let me check in 1 second. It's a marker 3D now. Okay. And let's rename this marker to aim. For now, we'll just put this marker where our cannon should fire from. In this case, it should fire from here. Perfect. And now that this is all done and ready, we also need a way for our cannon to detect these enemies. And the best way to do that is by adding an area 3D. And you can call this mob detector. And that's, well, for the area 3D, we also need to add another collision shape. For this collision shape, I want it to be a sphere. And let's make it a bit big. Let's change the radius to 3.5. That will be the area of detection for our cannon. If the enemy walks in this area, the cannon will be able to shoot it down. And that's good. For the value of the detection, or the radius of the collision sphere right here, you can change it and tweak it as much as you want. This is, as I always say, is just a personal choice. We might even change this later on in the series. Now, we also need a node that will hold all of our bullets. So in case we don't need these bullets anymore, we can delete them later on. So, and for these bullets, we don't even need a node 3D. We're just going to add a normal node. We're going to call this a bullet container. And this is where we're going to contain all of our bullets that we shoot into our 3D world. Now, we need one more node to finish setting up our cannon, which is a timer, because we don't want our cannon to like spam shoot our enemies. We want a delay between each shot. And that's what the timer is. We're going to call this shooting cooldown. For the wait time, we'll leave it as 1 second for now. But we can start on with our cannon script. So we can just attach a script and we can save it in the scripts folder. Perfect. We can now open this up. Now, first thing first is we need a bullet. But we don't have a bullet scene yet, so we're going to keep this as empty for just a second. We'll go back and create a bullet scene right after this. So we want another variable. Let's call it bullet damage. This will indicate the damage that our tower does. For now, let's put it as 5. And we also need a variable that will keep track of the current targets in our area 3D that we created earlier. So we're going to do the variable. So we're going to do var current targets, and it's going to be an array since we can detect more than just one enemy. We're going to give it an empty array for now. We also need var current, or just say cur for short, and this is going to be a character body 3D. And what this is basically the character body 3D that we made for our enemy earlier. So these are all of the targets in our area, but this is the current target that we are shooting. That's what basically this says. Now, we also need another variable called canShoot to check if we can shoot or not, or are we still on cooldown, which is going to be a boolean, and it's going to be true by default. Now, let's actually start by getting a way to detect our enemies. And to do that, we're gonna go to our mob detector node. We're gonna check if a body has entered our area. We're gonna connect it to the cannon script. At the same time, we want to check if a body left the area, so we can remove it from the current targets array. That way, we don't shoot a target that's already out of our reach. And now, what we need to do is, I want to be able to check that our target is indeed an enemy that we should be shooting down. Now, we did not do this for the UFO earlier. We did not indicate a way to know if it's an enemy or not. That's why we're going to do it right now. We're going to go to UFO. We're going to click our character body. We're going to go here into groups. We're going to do enemy. We're going to click add here. Now, our UFO is classified as an enemy back in our cannon script. Now, for us, when we want to check if it's an enemy or not, all we need to do is going to do if body dot is in group enemy. And if it is in the group enemy, all we need to do is just, for now, let's do pass. Or actually, we can just add it to the array. So we're going to do current targets dot append. We're going to add the body to it. Perfect. Now, we're basically going to do the same exact thing over here when the target leaves our range. So we're going to do if body is in group. So the body is indeed an enemy that left our range. We're going to do current targets, which is the array that holds all of our targets. I'm just going to erase. I am pretty sure we have that function. Oh, my bad. A lot of typos, huh? Now, we need to create a function. Now that we have all of our targets in one array, we need a function to choose one of these targets to set as our current target. And we want to choose the enemy that is closest to our, let's say, castle that we want to protect. That's the enemy that we want to shoot down first. So we're going to create a function called choose_target. So we're going to do func choose_target. And we want the list of our targets. So let's say current targets. And it's an array. And this function is going to be a void, of course. Now, what we want to do is we want to create a temporary array that will hold all of our targets for us. So it's going to be a type array equals current targets. Now, we want a variable that is our current target, and it's going to be of character body 3D, and it's going to be null. Now, we're going to go through all of these targets. So we're going to do for I and temp array. We're going to check if our target is null. So if current target equals null. So if it is null, we don't have a current target. Let's set the current target to I for now. Now we're going to do else if the current target is not null. So we do indeed have a target. We want to check if it is the closest, if it's closest to our castle that we need to protect. Otherwise, we can switch to a target that is more farther away. Now, so we're going to do is if I get parent, so we can get this node right here. So let's go back to the cannon script, .get parent. And now that we got its parent, we want to get the progress, the same function that we used earlier to move our player. And we want to check if this target's progress is more than our current target .get parent. Let's actually bring this out so it is easier for us to see. .get parent. And we want to get progress. Perfect. we will compare both of these progresses. And if this target is closer to our castle, we want to switch over to that target. So current targets equals I. Perfect. Now we can go out of this for loop and change our cur, which is this variable, to our current target. And this is how we choose our targets. Now, I want to call this function every single time we add a new enemy and every single time we remove an enemy. So if the enemy just came into our area of detection, I want to check if it is closer, or if there is no target at all. I wanted to choose that target to shoot it before it reaches the goal. So after we append it to the array, let's do choose target. Let's give the array right here. We're going to do the same thing here. So choose target, and let's give it the array. And this should work perfectly. To check if it works or not, well, we cannot check right now, actually, since we did not add this to our world scene, which we should do in a second. But let's let's add it to our world scene real quick, so we can check that it is actually working. Let's go to our scenes, and here we have our cannon. And as I said earlier, it fits the same size, so let's put the cannon a bit up. Let's give it, let's see, where's the transform? 3.5, since we need to put some offset to it. We forgot to turn on the snapping. My bad. So minus 3.5, so it snaps perfectly. And let's add a bit of an offset on the y-axis, so 0.20. My bad. 0.25. I want it above the ground. I think that's a lot, so I think 20 is fine. Yeah, 20 is perfect. And here, I think the range is a bit too big, so we need to go back to the cannon and tune down the range a bit. Let's do 1.5. I think that looks a bit better. That looks a bit better for now. I'll actually move it right here. And now let's go back to our script. I wanted to print every time it chooses a target. So I wanted to print cur dot name. So, and every time a target also exits the area. So now we can go back to our roll scene. We can start this enemy, 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 and of course oh yeah, of course, this did not work here because current is now equal to null since all of our targets left the range. So this set back to null right here. And we're trying to access the name, so that's why it didn't work. That's why it gave an error. But don't worry, this won't give any errors to the actual game, since the print should not even exist when you finish working on this. Now that we know our detection works, we can move on and create a small bullet scene. For our bullet scene, we're going to go right here. We're going to open up the 3D scene. Sorry, I said 2D. Let's close this up. And for our bullet, the bullet needs to be a character body 3D. And let's rename it to bullet. Now, what our bullet needs is a mesh. So I'm going to use CGI mesh 3D. Since I don't really have a mesh for a bullet, we're just going to do a prism mesh. That looks really nice. And let's actually play around with the transform a bit. So first of all, I want it to face the forward direction, so we're gonna do 90 degrees. Yep, it is facing the forward direction. And I want it to be way smaller because this is a lot. This is a lot. So we're gonna click here. Let's change the size from 1 to, let's say, or you know what? We can leave the size as it is. We can go back to it later. We're going to change the entire character body size instead. So let's add a collision shape. And it's going to be a polygon. No. Let's do a box shape. And this should work for now. Perfect. And for our collision, we also need an area to detect if we are touching an enemy or not. So we're going to do area 2D. And we want this to have a collision shape. And the collision shape is also going to be a box, but it needs to be a bit bigger than the actual collision shape of the object. Since this is needed to detect if it is touching, you need to turn off the snapping. I always forget to turn it off. Since it is touching the enemy or not, and not just bounce off the enemy. So it just needs to be, let's actually make it a bit bigger. It's fine. A bit bigger on the sides. And that looks perfect. We will rename this area to let's say collision, since this will detect our collision, and we can save it in our scenes. Now, the bullet also needs a script. So we're gonna do that. We're gonna attach a script to it. We're gonna save it in our scripts folder, like always. So bullet.gd, and we're gonna hit create. Now, what our bullet needs, it needs a target. So we're gonna do var target, and it's a character body 3D, which is gonna be our enemy, our UFO. And we also need a speed for our bullet to travel. So we're gonna give it a speed of 20. And we also need bullet damage. So we're gonna do bullet damage of type int, but we won't give it a value, since the bullet damage is determined from the tower itself, right over here. Perfect. Now, the bullet script is fairly simple. All we need to do is a physics process function. And in here, we're gonna check if is instance valid. So it checks that our target is valid and it's not null. That means we do have a target. We want our velocity to equal, actually make this a bit bigger. We want our velocity to equal the global position dot direction to target dot global position. This way, it will move directly to our target. And we also want it to face our target, so we're going to do look at target.global position. And we're just going to do move and slide. That's basically all we need. Now, if our instance is not valid, or our enemy has been deleted, we also want to delete this bullet, since we don't want it to be following an imaginary target. Now, what we also want is, we want a way to check that we touched the enemy. So we're going to do func. Actually, this is not a function that we should write on our own. I think we just need to connect a signal for a body entered 3D, sorry. After we connect the signal, let's go back to our script. Oh, perfect. Let's go back to our script right here. We're just gonna check if the body that we touch is in group enemy, then I want the body to take damage based on the bullet damage. And we want to delete the bullet. What take damage is a function that we will add to our enemy right now. So we're gonna do func take damage, and we pass damage if I'm not wrong. So we're gonna do damage is an int, and it's going to be of type void. And in here, we just want to do health minus equals damage. That's basically it. Now, the bullet now deletes itself, but we also want to check if our health is below 0. So we're going to do if health is below or equals 0, then we also want to delete the enemy. Now, that's basically our bullet. We can go back to our cannon. I'm gonna do preload fish reload. We're gonna go for scripts. No, it should be in scenes. Let's actually look for it. Bullet. So close that up real quick and let's do bullet. Perfect. And we forgot to define this as a packed scene, so it is easier for us later on. Now that we can detect our enemy, we need a way to shoot this enemy. And to do that, we're just gonna create a function that's called shoot to keep everything organized. So we're gonna do func shoot, and it is a type of void. No, that was by mistake. And what you basically need to do is just instantiate a bullet and just give it a target. So we're gonna do var. Let's call it temp bullet, and it is a character body 3D, and it is, let's actually make this a bit bigger, and it is a bullet dot instantiate. Now that we instantiate the bullet, we need to give it a target. So we're gonna do temp bullet dot target equals current. We're gonna also give it the damage, so bullet damage is equals to bullet damage right here. Did we call it bullet damage? Yes, we called it bullet damage. And that's basically it. Now we just need to shoot it and add it to our scene. We're gonna add it as a child of our bullet container. So if I'm not wrong, we go back to Canon. It's called a bullet container. Yes. Bullet container dot add child, and it's the temp bullet. Now, I want the bullet to come out from the position that we set earlier using our marker 3D, right in front of the cannon's entrance. So we want to do temp bullet dot global position equals, say, what did I call it? 1 second. We can just drag and drop this. We need to close this first, drag and drop. So we're just gonna do dot aim dot global. Actually, I want aim to be inside of the mesh instance so it doesn't cause us issues later on. So we're gonna do aim dot global position. And that's basically our shoot function. Now, even though our shoot function is there, we never really called it before. And that's because we need now to create the logic that it checks, and if we have a target, and if we do have a target, we want to shoot that target. And this is when we're gonna start using our shooting cooldown. But for now, let's actually create a func process. And in here, we want to check if is instance valid. We want to check if our target is valid. And if it is, we want our cannon to look at the target. So current.global position. And we want to check, now that we're looking at it, I want to check if I can shoot it. So if can shoot is true, we just want to shoot. We want to switch can shoot to false. And we want to start our timer. Dot start. This way we can have a shooting cooldown or a delay between each shot. Now, in case our instance is not valid, else for I, we want to check all of the bullets in our bullet container in get node bullet container. As I said earlier, that's why we add the bullet container, so we can delete the bullets if we have no target. So get child count. I want to do get node. Want to get the same node again. Dot get child, and we're gonna give it an index, which is I. I'm just gonna delete it. So we're gonna do Q3. And that's basically the logic for our cannon. So if everything goes well, our cannon should function perfectly. We need to save everything and so actually close this, and we can test run this scene. And global position in base marker. Did I misspell anything? Let's push this outside. Aim dot global position. I don't think I misspelled anything. Oh, it's not a function. It's not a function. I added that by accident. Let's try it again. It works, but our cannon does not reset since the cooldown is not working perfectly yet, since we did not add the timer yet. Now, let's add the timer. Let's do connect. And now, when the timeout signal is here, we want to set can shoot to true, so the cannon can shoot again. And we also forgot to downsize the bullet, and it was way too big right now. Just want to select the bullet and go to transform, and for scale, let's put it to 0.1. Let's try that again. Let's go back to our roll scene. It does shoot, but the bullet is really slow. And the cannon is facing the opposite direction. And a quick fix for that is just go to the mesh instance, transform, and just rotate it by 180 degrees on the y-axis. Now, let's check this again. The cannon looks at the targets. Our UFOs are huge as well. We need to kind of make them a bit smaller. So we're just going to go, don't change the transform for the path follower 3D, but change it for the character body. So we're going to go to transform. Let's make it let's do 0.6. I think that will look nice. Yeah, that looks a lot better. But our bullets are still way too slow. They are not even reaching our enemy before the enemy goes out of range and the bullets get deleted. So we want to change the speed from 20 to let's say 100. Let's run this again. That is really slow. Oh, I forgot to actually multiply it by speed. That was my fault right there. We can set this back to 20. And now the bullet should be flowing way faster. I don't even see the bullet for some reasons. Let's see. Did I do something wrong? No, everything looks perfect here. So let's see. What is going on? Why is it not shooting anything? Oh, is it shooting, but it's way too fast? Oh, it is shooting, but we can't see it because we have bad lighting in the scene. And I think we should fix that as soon as possible. But for now, our cannons do actually shoot, and let's just check real quick that we're actually damaging these enemies by going to the enemy script, and let's put down their health to 1, so they get killed with one shot. So you can see when our cannon hits the enemies, they disappear, since one hit is enough to kill them. And now we have a working cannon in our game. What we need to do now is set up a way for us to place these cannons manually, and yeah, that's what we will be working on next time, and maybe improve a bit the lighting in the scenes. We can't even see the bullet right now because of the bad lighting.
Hello there, how are you? In this new lesson, what we are going to be doing is that we are gonna start creating our shop system, okay? And of course this will cover a lot of lessons because there are a bunch of things that we have to create. But the first step to actually create our shop was the UI that currently it is completed. But the following thing that we want to create is an auto-load script, okay? So basically with auto-load scripts, what we are able to do is to create some global variables that then we can modify, and also global functions that can be called and modified if they are variables in literally any script. So basically a global script whose variables and functions can be quickly accessed. So this global script is the one that we have, for example, our save and load functions. And by making it an auto load, it will allow us to actually call these functions in literally any script without having some problems. So to begin with this, here on our file system, we will just right click here on the resources, create new script. Okay, I'm gonna give it the name of global, and I'm gonna click here create. And you can see I have here my global script that I can open. But well, this script isn't actually like an auto load until now, because it's just like a normal script that doesn't have a node attached or anything like that, so it won't really work. However, if we go to project settings, we have here this option of auto load, and as you can see we can add it right here. So let's look for global, and you have to give it a node name. Basically you can click here add, and here you will be able to modify the name. Basically if I leave it like this, global with capital G, and for example I'm gonna create here a quick variable like something like score, that's gonna be an integer. This is just an example again, and I go to my player, and here when I'm moving I wanna increase the score of the global script. The only thing that I will have to write is global. As you can see, by the way, here Godot helps me, global.score, for example, and I would be able to add 1 to this value. So here this is the node name, okay? You can use this default name. However, I want to use just everything in lower cases so that we keep coherency in all of our objects. But well, feel free to adjust this name as you want. So, and with this you will have this auto load script. So let's for example try something out. Actually two things out. First of all, I will create again a variable for this, for example again score, that's gonna be an integer, and I will then create here a function of I don't know, show message, for example. And the only thing that I'm gonna be doing here is printing hello, okay? And this isn't gonna be returning any value. Okay, so what I want to do are two things. For example, here on the player movement, when I'm moving, I'm gonna be calling here global dot show message. Let's copy here the name dot show message. So basically every time I'm moving, I will have here on the output print hello. So let's try this out, and you can see it does happen. For example, look here at this number, and as you can see, well, it does increase, so everything's working fine. And on the other hand, let's for example increase our score. So I'm gonna call global.score plus equal 1, and then I will print out this value. Okay, so we are both accessing variables and also calling functions. I mean, we previously called the function and now we are accessing a variable, and then, well, just to verify that everything's working fine, we are just printing the value out. Let me check here again. I'm gonna make this a little bit smaller, and as you can see, my score increases and the value is being printed on the screen. So this works perfectly fine. So let's just delete here these quick tests that we created like this. And on our next lesson, we're going to be creating the global variables of our global script. Hello there, how are you? We are here in a new lesson. In our previous class, we were able to create an auto load script named global. And well, we were trying out some things to access variables, modify their values, then finally print those values out. And also we created a function that will just print a message. So now you do have a general understanding about how our autoloads work, how they are used. So in this specific lesson, we are going to start declaring the global variables that we will start using. Okay, so the first variable that we are going to be declaring, and it's actually going to be the most important variable in our global script, is our data. Okay, so basically this will be useful for when we want to store the data in files. So I'm gonna name it data, and the type of variable will be a dictionary. Okay, so if you press Control and then click here, you will be redirected to the documentation where you will be able to find a lot of information about dictionaries. But as you can see here, the important thing is how they are declared with these two symbols, and then that dictionaries store a key name, and then each key has its own value. Okay, so it's quite simple to actually understand dictionaries, and we can even save dictionaries inside of dictionaries. Okay, so let's go step by step. So I'm gonna assign here a new dictionary to this. And well, what I firstly want to store are the different values that will have the value either true or false, depending if we have if we can use the different players. So basically I will create here a variable for pink, red, violet, and yellow, and I will assign a value of true or false depending if I have this skin or not. So for example, let's start here with pink. Make sure that you are using the correct spelling. And well, initially we won't have our pink skin, because remember that the default one is our violet skin. So let's assign here just a value of false, and then here followed by a comma. Okay, and then we are able to declare the following key and value. The following is red, that again is gonna be false, and then we do have violet, that in this case, sorry, here it should be like this, violet, and here we do have by default our violet skin, so that's why it's gonna be true. And finally we have yellow, and of course we don't have that unlocked by default. And like this we have the different values of our data. So let's for example try this out. So what I'm gonna create is a brand new function that is gonna be a test. So print, I'm just gonna here print data. This isn't gonna be returning anything, that's why I'm writing here void. And for example, let's print here data, and then between these symbols we can write here the key name that we want to print. So for example, if I want to print here the value of violet, I will just write here violet. Okay, and with that I will print that value. So for example, when I'm moving, I will again call global dot print data. Okay, and now when we play and I move my player, this is gonna be printing true. Why? Because violet is true, as I have said right here. Okay, these values can be modified, of course, because for example we can call here data violet equal true, and then if we print this value, okay, and let's play again, as you can see now it's printing true. Sorry, but here it should actually be false, for example, so that we see there how we modify the value. So I think that's quite easy for you to understand. And now the other thing that you have to know that is quite useful is the fact that sometimes, as we are going to be storing all the data in just one dictionary, it will be maybe useful to store inside this dictionary other dictionaries. Basically, as you can see here, we have different things that we want to store. First of all, I think that we want to then, save and load. So what is the data that we want to save and load? The data that we want to save and load is are the players that we have bought. So basically those are the items. So that could be a complete dictionary inside of this data dictionary. And also the other thing that we have to say that we created in our last lesson are the coins, okay? And also finally there is one other variable that we are gonna be needing to store, and that is the selected player index. Because well, here this first skin would be index 0, this other one would be index 1, 2 and 3. So then we would be able to actually change these skins, okay? This will make much more sense in the following lessons. So here the key thing is that you understand that you can save dictionaries inside of other dictionaries, and how you do that is also quite simple. I will create here this new dictionary that I'm gonna name items, and I will just here assign a brand new value, okay? And inside here I will just cut and paste the corresponding values, okay? And here I have it. I have my data dictionary, and inside of my data dictionary I have a dictionary called items, and inside these items dictionaries I do have my different keys and values, okay? Finally, let's create the other two variables that we are gonna be using, and that is my selected player index, okay? That the initial index will be 2, because as I told you, this will be 0, this one will be 1, this one will be 2, and the default one is violet, so that's why it is 2. But then maybe this value changes due to the fact that if we, for example, have selected the pink skin, well then this will store value 0, if we select red it will be 1, etc. And then finally also the coins, okay? So, and right now we have to also write here a comma, and with that all errors will disappear. And before finishing with this lesson, let's actually use this value of coins instead of the coins that we used right here. So this is quite simple. Let's just erase this value, and here we'll just call global dot data, and here we'll be able to access the coins key, and I will just increase it by 1. And then we also have to use this value over here, and then here we also have to update this, but instead of writing here just this that would work, we are actually gonna be using the coins as text a lot of times in our code, okay? So in order to simplify the process a little bit, I will create here a function on my global script that I'm gonna call get coins as text, okay? And this is gonna be returning a string, okay? And basically what I'm gonna be doing right here is just return, and what I'm gonna return here is the coins text, basically the coins label text that I wanna set, and that is my dollar symbol plus converting into a string my coins, okay? So basically right now over here we can just assign our coins label text to global dot and here directly paste this function name, okay? And there this will work as well. I will here also remember to erase this print data function from the player. And well, as you can see now I can increase it, okay? The only thing is that I'm increasing 1 by 1, and what I want to do is increase 100 and 100 every time that I press it. And as you can see, it has the exact same logic that the same result that we used to have, but well, now the process is a little bit different. So now with this we are gonna be able to actually be storing everything in just one dictionary that then we will save and load. So see you in our next lesson. Hello there and welcome to a new lesson. Today what we are going to be doing is that we will create the path where our files will be saved, okay? Basically we'll start creating the save and load system, and for both systems we will have to have a path where our file that will store our data will be saved, okay? And in order to actually start understanding this, what we have to do is to first understand how file paths work in Godot projects. Okay, so I really recommend you to go to the Godot docs and take a look at this section over here. And well, here you will have a general understanding of how file paths in Godot work. As we want to save information that has to be persistent, that's why we're going to be using this part over here of the documentation that is accessing persistent user data. To store persistent data files like display, save, or settings, you want to use user instead of resources as your path prefix. This is because when the game is running, the project's file system will likely be read-only. In order to understand this completely about resources and user path, you can take a look at here, but in order to only focus on what this course is about, we will only be talking about the user path. So basically something general that you have to understand is that user prefix points to a different directory on the user's device. Unlike resources, the directory pointed at by user is created automatically and guaranteed to be writable to even in an exported project. So basically, if we, for example, go to our Godot project, you can see that here we have the resources folder. So basically, with the resources file path, we would be creating a file inside of our project. But it will just be saved like in our project files, and that's something that we don't want to do because we'll have some permission issues, and also maybe the data isn't saved or loaded correctly. That is basically what Godot is telling us to do, because here it's telling us to store persistent data files like the place, save, or settings. You want to use user instead of res. Okay. So here you have where the location is of your directory for users, okay? And here, depending on your operating system, you can have one path or other. So basically, we will be able to find the file that we save in the following path, okay? So once we do understand that, and we will actually see that in our next lessons, what we are going to be doing is that I will create here my path variable that is just basically gonna be a string. And in order to assign a value to it, I will first of all copy this that string, and then I will assign it over here, and then I will write the file name for my file, okay? And in this case, I'm just gonna name it save. You can name it in literally any way that you want, and then we have to provide an extension for our file that is gonna be using txt. This is the format that is used in just text documents so that we are able to quickly use it. And with this, we do have created our path, and you should also have understood a little bit about how file paths work. Remember, if you want to take a deeper look and understand more things, you can always refer to the Godot documentation. But the important thing here is this line, okay? If you want to store player save or settings, you have to use user because it's a path that is outside of our project files. Unlike resources, that is just a directory inside of our Godot project. Having that understood, in our next lesson, we will start creating this save and load system. Hey, in this new lesson, what we're going to create is our save system. So let's go to our global script where in our previous lesson we created our path and we explained the differences between user paths and resources path. That resources is just the directory inside of our project, and user is a different location that actually will be able to store data. So let's start with the save data function that I'm gonna be creating right here, okay? I'm gonna call this function save data. This isn't gonna return any value, so I will just write there void. And what we need here firstly is to open a file, okay, at a certain path, and then there we will have to write. Basically, when you write, it means that you are inserting some kinds of information into that file. And as here we are saving data, if we want to save the data, it means that we want to write on that file. We want to do some kind of modifications. We want to write the variable. And which variable? Our data variable. So let's go step by step. So the first step will be to create a file variable that will actually store our file access reference that will allow us to open the file at a certain path with a certain permission. Okay, so the type of this variable will be file access. For more reference about this, you can hold control and then click here. And you can see here you have the clear function that it provides methods for file reading and writing operation. That's exactly what we want. And then this will be equal to file access. And here file access, we will use the open method. And as you can see, now it will require us to give it a path, and the path we have already created it in our previous lesson. And then we have here different options, read, write, read. And basically, as I told you, what I want to do here is to put some information there. So what we want is to actually just write. Then what we also want to do is to create a kind of temporary variable that then we will store into our file. Remember that our data is a dictionary, so I'm gonna in a way be storing this dictionary inside of other dictionaries so that we can actually store it as a var. So this is gonna be, I'm gonna just name it game data to give it a different name. This is gonna be a dictionary. So I'm gonna assign here the values. I'm just gonna call here the key data and the value just my data dictionary that I have over here. And once I have that, as I told you, this is basically a copy of our data variable that then we are gonna be storing. Okay, and to store the variable, we'll just call file. That what file will actually do is to open a file at this path and write. Okay, and once we have that writing permission, we will basically store a var. Okay, and as you can see, the value that we want to store there is our game data. Finally, we have to close the file. Okay, because if not, the file will always be open, and we don't want that. So that's why we are closing our file. So let's go over the lines that we created. First, we declared here the function. Then we created here a variable that will actually give us access to the files at a certain path that we created, and then on that path we would write on the file. Then we would create a reference to our game data that is a dictionary, so we will store a dictionary inside of other dictionary. And then we will store this variable in our file. Finally, we just close the file, and there we have successfully saved our data. In our next lesson, we will actually load the data. Okay, so see you in the next one. Hello there and welcome to a new lesson. This time, instead of creating our save data, we are going to be creating our load data function. So let's firstly start by declaring the function that I'm gonna just name it load data inside of our global object. Of course, it's not gonna return any value, that's why I'm writing void. And here the beginning of the function is gonna be quite similar to what we did in our save data, due to the fact that we are gonna still be opening a file at the same path, but in this case, instead of writing, we're gonna be reading the information. Okay, why do we want to read information? Because as I told you, when we write information, it means that we are modifying the information. We are storing something, we are adding something. That it is what happens here. But here, when we are loading the data, we don't want to store anything or update or modify something. The only thing that we want to do is to read the data, to get the data that is in our file. And in order to do that, we're going to do something quite similar. I will just create here my file function of type file access. And then this will be equal to file access.open. The path I have already declared it a couple of lessons ago. But then here, the file access needs to be read. Okay. Now, what we want to do next, in order to avoid any issues with files creation, that maybe there was some kind of error and this file somehow doesn't exist, or is this first time that we are playing it, literally to avoid any kinds of errors, we're gonna be checking if the file doesn't exist, return. Okay, so basically make sure that the file exists. So I'm gonna call here if not file access dot file exists at the same path return. Okay, so we'll always make sure that the file does exist. And then what we want to do is to get the variable that we stored here on our save data. So I'm gonna give it the same name that I gave it over there, that was game data, but in this time the type will be just variant. Okay, and how do I know that? Because then I have to get the variable that is inside of our file. So basically file dot get var, and as you can see here the documentation will tell us returns the next variant value. Okay, so that's why it's gonna be variant, because by the way, what we can store here can be anything from a dictionary to a boolean to a string to whatever we want. That's why it's gonna be variant. And once so basically here the game data will have the previously saved data that we had saved. So basically this will be like the updated information. Okay, so now with this updated game data, we have to update our old data that we used to have. And in order to do that, it is quite simple. So we will just make equal our data to our game data, and here the key data. Because remember that inside of our game data, we have a key that is called data, that basically will have the value of all the data that then we store. And finally, as we did with our saving function, we will just close the file.close. Okay, now even though we have successfully created the system, we can't actually save and load data because we aren't calling these functions and we aren't updating here our data, then saving the data and then loading it back again when we start playing. So that is something that we will start creating in our following lesson.